10, 9, 8. The silent countdown continues, not in a bustling control room filled with cheering crowds, but in the vast, cold emptiness of deep space. Against a backdrop of impossibly distant stars, a tiny solitary craft presses onward. It is Voyager 1. This remarkable machine left our home planet in 1977. A different world then. It has journeyed farther and longer than any other human-made object, a lonely pilgrim on an endless road. It continues to send faint whispers back to its creators, signals that take nearly a full day to reach us. Today, this tireless explorer is about to make history again. Voyager 1, one of our species' most profound achievements. Attached to its side, a golden phonograph record. Sounds, images chosen to portray Earth's diversity. The golden record, a message in a bottle, a greeting for any civilization that might find it. The probe is equipped with cameras, antennas, and an array of scientific instruments. It was designed to be our eyes and ears in the outer solar system. The mission was born of a rare planetary alignment, once every 176 years. A single spacecraft could visit them all, using each world's gravity to slingshot it onward. In 1977, NASA launched two, Voyager 2 and Voyager 1. Voyager 1 was sent on a faster, shorter trajectory to reach Jupiter and Titan. In 1979 and 1980, it revealed raging Jovian storms and active volcanoes on Io. Then Saturn, thousands of ringlets, and Titan's thick, nitrogen-rich atmosphere. Flung out of the solar plane, its cameras were turned off in 1990 after the pale blue dot. From then on, an interstellar scout. For decades after its final planetary encounter, Voyager 1 journeyed through the outer reaches of our solar system. It traveled through the heliosheath, the outermost layer of the sun's magnetic bubble. The heliosphere is carved by the solar wind, a supersonic stream pushing back the matter between stars. It protects our system, including Earth, from harsh galactic cosmic radiation. Then, on August 25, 2012, something remarkable happened. Solar particles plummeted while galactic cosmic rays soared, the crossing the world had waited for. Voyager 1 had crossed the heliopause, the boundary where the sun's wind is stopped by the interstellar medium. Beyond lay the vast sea of particles and radiation between the stars, the first human-made object in interstellar space, monumental. Today, it is over 16 billion miles, more than 26 billion kilometers, from Earth. A command at light speed takes more than 24 hours to arrive, and another day to return. Despite its 1970s tech, it endures, our lone outpost in the interstellar ocean. Even in the profound emptiness of interstellar space, the journey has landmarks. As of today, October 19, 2025, NASA is watching closely. They believe it is nearing another subtle, significant milestone. Though firmly in interstellar space, the sun's distant influence lingers. The interstellar medium isn't uniform. It's complex and dynamic. Our heliosphere moves through this medium, draping and disturbing its fields, much like a ship's bow wave. Soon, Voyager should enter the undisturbed, pristine interstellar medium. Instruments will look for stabilized field directions and plasma wave changes. A transition to a truly new environment, our first baseline of the galaxy in its natural state. Crossing in 2012 was the surf. Now we swim past the breakers into the calm beyond. These data guide models of our galaxy and its magnetic fields, crucial, yet uncertain. The universe often surprises. Communicating with Voyager 1 is an exercise in extreme patience and precision. Its radio signals are astonishingly faint by the time they reach Earth. The transmitter is about 23 watts, roughly a refrigerator bulb. After billions of miles, the received power is billions of times weaker than a watch battery. The Deep Space Network, giant dishes in California, Spain, and Australia, serve as Earth's ears. Their sheer scale boosts whisper-thin signals and teases them from cosmic noise. A focused uplink travels for a day, and another day for the reply. Every interaction is deliberate. The data arrive as numbers from a few stalwart instruments: cosmic ray, low-energy charged particles, the magnetometer, and plasma waves. Each tells part of the interstellar story, a cosmic weather report from the frontier. With dwindling RTG power, engineers choose what to keep alive. Creative, careful triage. In 2023, a command bypassed a faulty chip, a feat of long-distance robotic surgery. This next milestone helps define the sun's true reach, its shape, size, and changing edge. Is it comet-tailed or more spherical? How does it ripple with the sun's 11-year cycle? Voyager maps the boundary from the outside, our first external perspective. The interstellar medium looks empty, but it's a diffuse soup: plasma, neutral atoms, dust, magnetic fields, and cosmic rays. Plasma waves reveal density, denser than expected, as Voyager showed. The magnetometer charts the invisible threads that shape nebulae and spiral arms. Now outside the shield, Voyager samples unfiltered galactic cosmic rays, keys to extreme processes. Tiny changes, field directions, plasma density spikes, cosmic ray energies, trace the sun's fading reach. Slow, meticulous work, decades of data becoming a new map of our neighborhood. A map drawn by a single robotic trailblazer. Beyond the science, this is a human story of dedication and ingenuity. Built with 1970s tech, computers with less memory than a car key fob, yet kept alive for nearly 5 decades by teams who solve problems a light day away. Detectives with limited clues, sending carefully crafted code across billions of miles. With dwindling power, they turned off heaters and non-essentials to save the science. In 2023, a clever bypass restored data, precision from a world away. The torch passed. Knowledge spanning generations, slide rules to supercomputers. One NASA scientist put it simply: Voyager keeps teaching us. Pride, care, and wonder bind team to machine. The spacecraft is an extension of our curiosity, a proxy for all of humanity, and it still sends lessons home from the great dark classroom of interstellar space. As Voyager 1 nears a new threshold, we remember why we explore. Not for immediate gain, but to know what's over the next hill, beyond the next ocean, past the farthest star. It carries our questions, and on its golden record, our music, languages, and images of life. A messenger, a scout, a piece of us drifting through the galaxy. Its journey is one way. Around 2036, its power will fade. Instruments will fall silent. Its faint signal will cease, and the conversation will end. But the voyage continues, silent for thousands of years across the Milky Way. A ghost ship from a small blue planet, outlasting its makers. We watch and listen, waiting for the subtle change that signals a new chapter. Each discovery opens a door, teaching us about the universe and ourselves. A quiet victory about distance, time, and a question asked long ago. The universe is large. Our courage to send a voice into it is larger.